This video follows the experimental setup section of the 114P user guide. We're going to follow the daily procedures for preparation of the chamber, tissue dissection and mounting, equilibration, and an example of a startup or a standard start protocol. When preparing your system for the experiment, you will need to make fresh PSS and a high potassium PSS as well. In this instance, we will be making 60 millimolar kPSS. You can find these recipes on the DMT website in the 114P user guide. You will need to preheat 200 to 300 mils of your PSS for the experiment. Make sure that when you begin heating it, that you are bubbling the buffer. This will take approximately 20 to 30 minutes. After 20 to 30 minutes, we can now add our pre-warmed buffer into our P1 interface bottle. You do not want to add any more than 300 mils to this bottle. However, you should not need more than 100 to 200 mils max. Do not add your buffer while the bottle is sitting in the interface, as the bottom connection in here is not waterproof. So we will add approximately 100 to 200 mils. And reconnect the bottle cap. And make sure it is tight. The last step in preparing your system for your experiment is to fill the chamber lines with your PSS. You will need to make sure that your chamber is connected to the interface with a myograph cable, so you can keep an eye on how much pressure you are adding when you are pushing buffer through the lines. You'll need a syringe with a blunt 18 gauge needle and a bit of tubing. First, you can fill the chamber with buffer so you can see once the lines have been filled. We will start with the P1 side. You will connect the tubing to the open port, turn the three-way valve, and now as we push buffer into the lines, it will go through the pressure transducer and fill the right side tubing and cannula. You will need to keep an eye on the actual pressures and make sure that you do not pass 200 millimeters of mercury. You can see the bubbles start to come out as you fill the lines, and once there are no more bubbles coming out, you know that this side has been filled, and you can close the three-way valve to the chamber, and now you know that this entire side has been filled with buffer. We will now repeat the process on the P2 side. Again, looking for bubbles. And once there are no more bubbles, you know that you have filled this side with PSS. Once you have buffer in the lines, the chamber is now ready to have the tissue mounted, and the preparation steps have been done. For our purposes today, we'll be using a mesenteric artery. The mesentery is a good tissue bed to use, as there are many vessels that can be used as practice. Pin out a section of the mesentery. You will start by cleaning away the excess tissue. Take care not to touch the vessel with your forceps. Avoid any branches at all costs. Cleaning away excess tissue is more important for pressure experiments than it is for the wire. After removing the excess tissue, you will see the artery and the vein side by side. It is important to identify the artery, which has thicker walls, a smaller lumen, and will appear more white. The vein will often appear more red as long as blood is still in the vessels. You want to add as little stress as possible to the artery. You can cut away the vein. Now isolate the artery. You can place the clean vessel in a small container of cold PSS. You can now fill the 114 with cold PSS. Make sure that your cannulas are aligned and at the same height. Place 2 double-knotted sutures on each cannula. Carefully transfer the vessel to the 114 chamber. It is best to use a large bore pipette tip and a pipette or an eyedropper to transfer the vessel and minimize vessel handling. Carefully mount the P1 side. If you are doing a flow experiment, it is important that the P1 side is the upstream or the proximal side. You can use 2 different cuts to distinguish a straight cut and an angled cut. Any part of the vessel that touches the cannulas will be damaged. So you will add your sutures towards the tip, but not too close. Once you have the P1 side mounted and secured, you can use a syringe with tubing attached to the P1 three-way valve. You want to make sure that you do not introduce any air into the chamber. Then you can push some buffer through the vessel and you can remove all of the blood from the lumen. This will also help open the distal end. You can then close the three-way valve. Switch to the P2 side and move the P1 cannula so your vessel is at the optimal distance for mounting on the P2 side. Slide the vessel onto the P2 cannula. Secure it with the 2 sutures. You can open the P1 side and add a small amount of pressure. The vessel should bulge and you should take note of the shape that it makes. Close the three-way valve while the vessel is still under pressure. If the vessel holds its shape and pressure, you know that you do not have a pressure leak and the vessel is good to go for the experiment. Cut and remove the ends of the sutures and transfer to the microscope. Once you complete the mounting, you will now bring the chamber back to the microscope and the system. First, you need to connect the myograph cable and all the accompanying tubing from the interface. Now, taking the same syringe from earlier, we will now charge the lines of the system, meaning we will draw buffer from the P1 bottle to the three-way valve and then use that same buffer to push it back into the P2 bottle and charge all of the lines of the system. So your three-way valves should be closed to the chamber. So right now they are open from this port back to the P1 bottle. Connect this and pull back until you start drawing liquid into your syringe. Once that is the case, you can then open the three-way valve to the tubing and the chamber. Now your right side, P1 side, is ready to go. To charge the left side, or the P2 side, we will now connect to the left three-way valve. Now the important distinction to note here when doing this step is to make sure that you have flow on while pressure is off. And then that way the hidden transducer in the interface will not be damaged as you push buffer through. So you begin to push buffer through until you start to see it come up from the P2 port and begin to enter the P2 waste bottle. Now this side is charged and we can close or we can open the left side three-way valve. The lines are charged and the system is ready to go. You can now place your chamber cover on top of the chamber and begin bubbling. Once the lines have been charged, we are ready to begin the equilibration process of the experiment. You can begin by turning on heat. When you do so, you must make sure that your chamber cover is connected to gas and the tissue chamber is bubbling. To begin, we can set P1 to 20 and P2 to 5. Before we turn on pressure, we will want to get a view of our vessel. We can click on capture, where we now see our vessel. But in order to get a good reading, we will need to adjust the settings to make sure that we get the best reading. You will then need to draw a box, click and drag a box across your vessel. Now you will need to adjust the settings to make sure that you are getting a good reading. In this instance, we will increase the light a little bit to get a good background, and also adjust our focus until we get into the middle of the vessel where the walls are thickest. And now we can adjust the focal plane until we reach the middle of the vessel where the walls are thickest. We can increase our light and also make settings adjustments on the camera itself. Now we have two good indicators of the wall, and we can start our pressure. You can see your actual pressures on the right side next to your target pressures. You can let this settings run for 2 to 3 minutes, which should flush any remaining blood cells from your vessel. At this stage, you can also begin to start data collection and begin your experiment. We have now started, and we can select which parameters we care to view. By right-clicking, we can select inner diameter and start to monitor the inner diameter of the vessel reading. After a couple minutes of this, we can turn flow off, as we do not want flow for the experiment. We will now increase our P1 pressure every 5 minutes by 10 millimeters of mercury. So we can change this to 30 and click change. Our pressure should now rise to 30, and we should see some distension in the vessel. You may have to adjust your camera settings until you get a stable reading. We can now change our P1 target to 40 millimeters of mercury. For our purposes in the video, we won't wait 5 minutes between every step. We can now change P1 to 50. We should see our vessel distend a bit more. You will increase by 10 millimeters of mercury every 5 minutes until your target pressure is reached. In this case, we are using a mesenteric resistance artery, so our target pressure is 60. So at this step, we have reached our target pressure. We will let this equilibrate for 5 minutes, and then we will stretch it and place it under longitudinal tension. After your vessel has been in place for approximately 10 minutes, you should replace the bath. So first you'll empty it and refill using your syringe. After you've reached your target pressure and the vessel is equilibrated, it is a good idea then to place it under longitudinal tension. You can do this using the micrometer on the chamber. Add stretch. You will want to make sure that you add the same stretch between vessels of your experiment group. You can double check this by using the force transducer on the chamber. You can now let the vessel sit for 20 minutes while it equilibrates at this new target pressure. After 20 minutes, you should perform one more washout. After approximately 60 minutes, we can begin the Wakeup or standard state protocol. After your tissue dissection and mounting and vessel handling, the tissue needs to be activated to get proper contractions and responses for your experiment. A few contractions are important to activate the smooth muscle cells and endothelial cells. An example will follow here, but other protocols are also relevant to achieve this aim. We will start with contractions with KPSS. We can start with a 3-minute exposure to KPSS. We should see a good vessel contraction. After 3 minutes or until a plateau has been reached, you will then begin your washouts. You should do 3 washouts with PSS over 5 minutes, and your vessel should return to baseline. After 5 minutes and your vessel has returned to baseline, we will repeat the KPSS exposure one more time. Now that a plateau has been reached, we can begin our washouts. By this stage, some level of myogenic tone should have developed. The amount of tone will depend on your vessel handling during dissection and mounting, the temperature maintained through the equilibration, the cleanliness of the vessel, and the quality of the buffers made. For the final test, we will add PE and ACH to assess function. After the response has flattened, you can now add the acetylcholine. The acetylcholine should have brought your vessel back to baseline. After this, you can do 5 washes over 30 minutes, and then you are ready to begin your experiment. For more information, please refer to the 114P user manual found on the DMT website or additional resource videos.